maybe three days should be sufficient to read week 2. Week 2 contents is basics of coordinate geometry, right? So basics of coordinate and the straight line. So that you study. So basics of coordinate geometry means you have to study the area of triangle, and from area of triangle you can get the collinearity, right? So that you can study. Also, what you can study is what else is there in the week 2? We have the basics of straight line, the triangle, and the triangle area. So those are the few things. I think, I mean, there are some formulas, and what are the concepts of slope. You can study, just check it. Then different questions of straight line. Okay, and so although, I mean, the x to the power 1 terms we have studied till now, right? So we have not gone to the x square, the quadratic terms. But if you can, revise the basics of also, basics of the brush up, basically just your class 9, 10 maths, class 8, 9, 10 mathematics. Okay? That will also be a little helpful, I think. Just take a class 10 maths book or some board exam maths book. I mean, that just look at the formula if required. I mean, no, you don't have to study trigonometry. We specially take care that the things that we have not taught, that should not come and that must not come in the exam. So obviously you have mostly no need to study trigonometry. It is good to have the basic concepts, at least know that sine 30 is what is sine, that what definition, that also might not be required, okay? May not be required. I mean, there is a hardly 0.02% chance something will be required, and even if it is there, it will be like it will be at least informed, like with the question there will be a note that this is the value you required and this is the thing. So there is, I think, just you can check, but don't like push towards trigonometry, that trigonometry may come, we have to study trigonometry. Trigonometry is not taught. Don't go something like that. Trigonometry will not come. Okay, and qualifier should not, as far as I remember. But anyway, no. Perpendicular lines does not involve trigonometry. Perpendicular lines means slope. Slope equals slope of the two lines is equals to product of the slope of the two lines is equals to -1, right? So that's the thing. And Tallam, are you from qualifier batch or from the quiz one? You can switch on your microphone. So we arranged this session for the quiz 1 students, and so if you are quiz 1 students, this is an open session for the quiz 1 students. Also, we invited the qualifier students so that they can brush up, and if you so if you although the discussion forum is still open, and you can always ask questions there. We are always looking at the forum, but if you still have any doubts on week 2, you can ask here. Yes, okay. So that is the agenda for week 2. Any kind of questions you have, that is the coordinate geometry basics and basics of straight line. Okay. Also week 3 also, if you have, we can just discuss. That's the basic thing. Achha, Amy has raised his or her hand. Can you switch on your microphone? We can talk. You have something to discuss? Amy has raised. Amy, are you there? Yeah, you can switch on your microphone, maybe. Okay, or you can type if you have some problem with your mic. Yeah.
Can I make themselves unmute?
Yeah, you can make. I mean, there is a yeah, sure. Go ahead. If there's a guys, just don't make noise. Okay, I mean, yeah, then we have problems to speak and all. Just
Sir,
Yeah. This is Ami.
yeah, this is sir.
Yeah. Okay.
Sir, can we talk on week one subject, sir? Discussion is anti-symmetric and asymmetric are confusing.
I saw your so this is Tallam also asked the same question. So and this week too we are not discussing on week one, but and symmetric you understood, right? Anti-symmetric,
Yeah.
asymmetric is not there in the syllabus. Okay.
Okay, sir.
Only symmetric thing is there. So we will just ask you to check symmetric. Anti-symmetric, asymmetric should not come. So and yeah. Yeah, and also if you want to ask any exact particular question on them, can you just ping us in the that
Okay,
Google
sir.
discussion forum? Yeah, just ping us. We will get back to you. Okay.
Okay,
I mean,
sir.
we were wondering why there is no questions on the forum.
Shortly I will message.
Yeah, just text us. Yeah, guys. So week 2 questions then we will study as it is 7:05 already. So yeah, you can post your questions in the chat box and we can start. If you have any questions on week 2, week 3, maybe. Week 2, we will just try to give it fast. And if you have not much question in week 2, we can discuss week 3 questions also. Straight line questions. Okay, I'll give you guys some time. So maybe we just brush up. So so Shrikar, this is for both. This is for both the batches. So this is for quiz 1 as well as for qualifier. We thought that as yeah. So you wherever you are from, you can ask. Yeah, I mean I got that anti-symmetric, asymmetric. Now we can yeah. Today too we have not prepared for that. You can ping us in the forum. We'll answer you. Okay. So by that time, what we can do is activity question 2.3, question number 3, Ram Deepak. Yeah, just a minute. Oh, so, okay. Before that, just a minute. I'm just checking the chat messages. Practice assignment 2.2, question 3. Activity question 2.3, questions. I'll just check the activity questions at first. It's important. Question 2.3. Yeah. So you guys can see my here I think screen. So yeah, Ram Deepak, can you switch on your microphone? Is that possible?
Yes, sir.
Yeah. So this question you are talking, if the origin cuts the line segment p minus 2 comma minus 4.
So I'm sorry, sir. It's question number 2.
The ratio in which the origin cuts the line segment.
Yes, sir.
This form.
Yes, sir.
Okay.
Yes, sir.
So yeah, what was the doubt?
So the answer is origin do not lie on the line segment, but I don't know how it came, sir. Could you please explain?
Have you plotted the line? I mean, in the have you tried to plot the line and see whether it is coming? Let's plot 2,8
No, sir.
and minus 3, so 2,8 And what is the other point?
I think so, -3, -2.
-2, is it? So then if you connect with so the origin utensil is not lying on the line segment, right?
Okay, sir.
Yeah, then there was a practice assignment question. Practice assignment 2.2, question number 3. Practice assignment 2.2. So that is Priyadarsh. Yeah, this question. What happened, Priyadarsh Singh?
Had a
Hello,
doubt
yeah.
regarding
Yeah.
as the bullet hits is there it is it's told that the bullet is fired at an angle tan theta is equal to pi. So what does that mean from the please explain.
The path of the bullet is assumed to be a straight line path if tan theta equals to 2/3.
Yes, sir.
Huh?
Yes, sir.
Yeah. Yeah. So you see, I mean, you just draw the line. Okay. And so what we have taught is, have you checked the solution? So here it is clear that so the path of the bullet. So this red point is the sniper. Okay. And he is firing the bullet at a, I mean, towards the ground, pointed towards the ground. Okay. So and it is from a height of 60 meters. So 60 meter is the 60 is our the y intercept. Okay. Now, so c equals to 60. Then the path of the bullet will be y equals to mx plus 60. So now m is the slope of the line, and we have already taught that the slope m equals to tan theta. Okay. So theta is from the negative axis. So basically, we are calculating it from the this towards the negative axis. This line, if you know we are the negative quadrant. So this the right side is the plus x, and the left side is the minus x, right? So towards this minus x, we are going up and up. So basically, from here, this line to this line here. Okay. So that is theta, and m equals to tan theta, and so then we can say that this is n equals to minus tan theta minus 2. So basically, tan theta equals to 2/3 means that your the slope is equals to minus 2. Okay, so the slope is equals to minus 2. So basically, y equals to minus 2. Okay, so that's what it means.
I wanted to ask that angle which we are taking from the x-axis, can't we take that angle from where the sniper is sitting with the horizontal?
So like you are telling as a parallel. I mean like so if you draw, I'll try to draw it a bit. Huh? I'm sorry. Maybe this is the ground. So this is the angle. This is our angle theta, right? Now you are telling whether we can take this angle, this A. Suppose this is this angle. You are telling whether we can take this angle.
Sir.
That is same as this angle only, right?
In that case, the upper, if we take theta, calculate theta from the sniper's point of view, then will we take the slope negative or that?
In that, no, the slope is always calculated anti-clockwise. Okay, so basically from here, anti-clockwise means it is going from here to here. Yeah, so this way we have to do. Okay. But I mean, as it is mentioning that it is with respect to ground, from that aspect, I think taking the this angle is will be easier, you know. Okay, just check whether the other thing works. If it works, then it's fine. Okay.
Thank you.
Uh, he has asked least square motivation. I think you mean the MAC, the mean square error. Is that what you mean? V. Hello. Yeah, you can switch on your microphone. So MAC is not out of syllabus. Okay, MAC is completely in syllabus. If it is practice assignment 1.2, last question, that is, I think the week 1. We'll just go back to week 1 later. Just go through. You can just ping us in the discussion forum. We'll tell you. Shubhrit, which question you are talking about? Shubhrit. Hello. Shubhrit, you can, which question you are talking about, you can just, I could not see your screenshot. Can you speak, I mean, switch on your microphone, then we can talk. Okay, by that time, we'll go to, we'll check. He has asked week 3, 3.5. So what is that? Hello. Yeah. You can tell me. I mean, week 3, 3.5 means which one? The activity question, is it? What is least square motivation? Can you switch on your microphone? See there, I don't know. I mean, we have a topic called least square motivation. We have MAC as far as I know. Tell we are just solving the IQ. I mean, week 2, week 3 questions. Given a set of the points, how to find the best fit line? Yeah. So basically, sorry, I mean, I was taking MAC. It is so basically, what you do is just you find the sum square errors of the. So you have not. I think you have checked the anything. The where is that resources from the SEA problem solving tips. Yeah. So basically, what you have to do is whenever this A is given, some table is given, you always you calculate the sum square error. So basically, the formula is this one. You can see the SSE is equals to sum of I from 1 to n yi minus mx minus c. So basically, you will be given 2-3 sets of equations, straight line equation, and you have to put the value in them. So if it is suppose y equals to 5x equals to 0 equals to 1 is given. Okay, suppose some equation is given. I'll show you. Suppose you are given an equation y equals to say 5x plus 6. Okay, y equals to 5x plus 4. Y equals to 3x plus 2. Some arbitrary equations. Then there is a set of the values x and y. There is a so like 1, 2, 3, 4, 5, 6. So then what we have to do is have to make a another sorry have to make another column. Then you have to write SSC of this is y1, y2, 3. Okay, so SSC of y1 done. Then another you have to do another straight line, right? Then you have to write SSC y2, and similarly you have to write SSC y3. Okay, so what you have to do here, you have to write say for y1, what you have to do is SSC y1 equals to so y1 minus 5x1 minus 6 whole square and sum of that. Similarly, you have to sum y2 minus 5x. I mean, so okay, don't go into this thing. So do you know that formula? You know that formula, right? That this formula SSC equals to yi minus mx minus c. That you basically have to utilize. So then what you do is you have to write. So for the first point, what we have is here 1 and 2. So 2 minus 5 into 1 minus 6 whole square plus then 4 minus 5 into 3 minus 6 whole square plus 6 minus 5 into 5 minus 6 whole square. This is your SSC y1. Similarly, what you do? Summation y2 minus this equation. Okay? This equation y2 minus 5x2 minus 4 whole square. Okay, then what you do is again 2 minus 5 into 1 minus 4 whole square plus 4 minus 5 into 5 into 3 minus 4 whole square plus then the last part 6 minus 5 into 5 minus 4 whole square. This is your SSC y2. Okay, so you calculate this way your SSC Y1 SSC, Y2 SSC, Y3. Okay, and you calculate which one of them is least. Okay, and that is your least error value, least error equation. So that equation is the best fitting line among the three. Okay, so that is how you have to calculate the best fitting line once you are getting a set of points. Okay, is it possible that the best fit line will not pass through any of the given points? Yes, it is possible. It is possible. Obviously, it is possible. It's a best fit line. It may not pass through any of the points. See, I mean that happened. I mean that is a real situation. See, my research is in humidity sensor, so I mean anyway that is not relevant. But for any, we have seen there are lots of data where the data points are not satisfying the best fitting line. The best fitting line may pass either, I mean, from one side of one point and another side of another point. That is our optimization. See, why are we studying basically the straight lines? Because ultimately we learn in machine learning the linear regression, right? That is where this forecasting and everything is coming to place. And for forecasting, you need the details of straight line, basically y equals to mx plus. So that is where these fittings will come in picture. See, if we take a fitting line with least square error value, and then we just I mean you know, we just forward interpolate it and understand what is the what is the next future value we predict. Okay. So that is the target of ACC. Bharat Mahindra. So we are covering week 2 and week 3 sessions this week. Okay, this session. So if you have any questions related to straight line, can just finish it. Okay, so that is that. And yeah, it is a good question that the best fitting line may not pass through any of the given points. That is true. That is very true actually. Okay. I mean, almost always we have seen this kind of. So maybe I can even show you the app. So if you search in Wikipedia for linear regression, it is okay if you don't know what is linear regression. It will be taught. See, study machine learning. Yeah. So see, you see this equation. See, this blue line is a fitting line, but none of the red points, they are actually satisfying the blue line. Okay. So the blue line does not go through any of the data points, but it is still the best fit line. There's no issue. So that is that mostly. So this is not required. Yeah, we just clear the topics. This is for week 3. Week 3 will come in a little later. We'll just brush up the topics of week 2. Although week 2 is very easy, we know. Still, we just I mean, there will be this is a scoring portion basically. Okay. So I mean, in your qualifier or quiz 1, all the questions from week 2, week 3 should be correct. Then I mean, quite a good amount of marks is coming. Yeah. So yeah, first we studied about Cartesian coordinates. Yeah, yes. So Cartesian coordinate is the coordinate system of yeah. So the Cartesian coordinates is a coordinate system specifying each points, and we know what is. So Cartesian was prepared. I mean, it is not required, but it was established by Rene Descartes, and after that, some other people were also there. Anyway, so this is our rectangular coordinate system, right? So we have the quadrants and the x-axis, y-axis. So you, yeah, maybe just switch on your microphone. It's flicking. So there is a one. The x-axis is also called abscissa. Y-axis is also called ordinate. But in your question, it will be mentioned as x-axis and y-axis because we generally take care that you do not get confused with the terminology. So mostly it will be, as far as we remember, we have consciously taken care that only the x-axis and y-axis is mentioned. So anyway, it is good to know the name. So x-axis is called the abscissa and y-axis is called the ordinates. First quadrant is the, as we know, the EM value is the, so this where both the x and y values are positive. That is called this coordinate. This is this quadrant. This is the first quadrant, right? Then the second quadrant is where the x values are negative, but the y values are positive, right? So that is sorry. That is this one. As you all know, I mean the x values will be negative and the y values will be positive. And similarly, third and fourth quadrant, where the third quadrant both the x and y values are negative, and in fourth quadrant the x values are positive, y values are negative. Distance in between 2 points is very important. So as I have repeatedly mentioned that please, whenever one coordinate geometry problem is coming, straight line or parabola from week 4, please try to draw it as early as possible. The whatever is taught, I mean whatever is told in the question statement, try to draw it. So I mean not even a coordinate origin needs to be drawn, okay, but just draw the lines. And so distance between any 2 points formula is there. So root of the distance between 2 points x1 y1 and x2 y2 is, so we'll if you forget to, if we brush up maybe, so if we have one line like this and we have a one point is x1, the point is x2 comma y2, then the distance between these two, right? Distance between these two is root over, sorry, so x2 minus x1 square plus y2 minus y1 square. Yes, sir. So this is your A value, the distance between the 2 points, right? Root over x2 minus x1 whole square plus y2 minus y1 whole square. The next thing is our A questions, the area of the triangle questions. So area of the triangle questions are like, as we know, 3 points are given: x1, y1, x2, y2, x2, y2. So in the chat box, you can ask your questions from week 2, week 3, or even week 4 maybe. Okay, if possible, if you want, you can ask. This is a open session, so we'll try to attend as much as possible. Okay. Please don't annotate on the screen. Area of the triangle is for week 3 practice assignment. Okay, thank you, Bharat. I'll just go. Just it's 3.2 question 10. Yeah, we'll just finish this discussion a little bit. So area of the triangle is represented with delta. So delta equals to this, actually formula comes from matrix, but that is not required. So half of mod means the magnitude we are only taking, half of mod. If we are having 3 points of the coordinates x1 y1, x2 y2, and x3 comma y3, then we have x1 of y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. And similarly, we have the section formula where if one line is cutting and another one point is cutting the line in two. Yeah, in internal and external cutting we have. So basically there are say if one point of P is cutting this line and of the coordinates x1 y1 and x2 y2, then in the ratio n and n. So there are two kinds of cutting. One is called internal section. So then the formula is mx2 plus mx1 by m plus x. Basically, all the signs are positive. Okay, you remember that all the signs are positive, and it is cutting external. So like the point is at a external point outside the line segment, then no, not the line segment. This is the line. The line segment is a little different. Then the signs are all negative. Okay, so that is your internal section and external section. And straight line, we have the straight line slope, as I was telling someone in the beginning, that slope. Yeah. Hello? Yeah, you want to use. Yeah. So the theta is the inclination of the line with respect to the x-axis, right? So the slope of
Can I
the
ask a question?
yeah, sure.
Can you explain a little more about internal and external ratios on the line, the previous one?
So basically, there are two ways to define a relation. The in between a point where the point is actually lying on the same equation of the line, straight line. So see how many ways a point can lie on the straight line. Right? So this is a line. You just mute yourself.
अपना नहीं हो तो नहीं है
So like suppose what can be is that see one way, this is a line say E comma A and B. Now the point can lie here on top of the line, okay? And it is in between the given points. Okay? So that is one case. Another case which can happen is that this point is on the line, but it is a bit outside. So maybe here. Okay, this is on top of this line only. Sorry. It is on top of this line only. But this blue point is actually on top of the given line segment, whereas this other point, this green point, see this, suppose this is x. This x point is not exactly on the line, but outside of it. So this thing, this blue thing, blue dot, blue point in which it has cut the line, that is called internal section. Okay. Now the next thing is external section. External section is this way. So see, now remove this blue dot. Did you understand the internal section, sir? Yeah, you can unmute yourself. Hello, who was talking?
Sir, thank you.
Yeah, so no, just wait. And this is internal section. Okay. So this is fine. Now the internal section is gone. Now we have to deal with the external section. Okay. Now you see what happening is that so at first, if it was internal section, suppose let's discuss about internal section only a little at first. So suppose this point P bisects this, intersects this line A comma B or AB in the ratio n is to n. So basically, the distance of this portion PA, that is n, and this portion is n. Okay. So in that case, it is going to be, you see this way. It is m, PA is m, P is n. In that case, this formula is given. So what is the coordinate of the P that you can obtain from this formula? That x equals to mx2 plus mx1 by m plus n. So basically, it is x1 comma x2 comma y2. Okay. So, and this one is say E Q. E is equals to m into x2. See, it is not m into x1. Okay, like our cross multiplication. M into x2 plus 1. M into x1. So m x2 plus n x1 divided by m plus n. That is our internal section. Okay. Now, if you see another line with let's say let's take a different color, black, and we have another point. Here. So we imagine that this point is on this line only. So if we extend this line A, B, and E, then this part is this point is on this straight line. Now, how do we generate a formula which relates this AB line x1 comma y1 and x2 comma y2 with this PQ coordinate? That is our external section. So what happens there? There we have a different formula. So like if one portion is in and another portion is in. So basically, suppose what we have is the distance from this complete point. So AP equals to N. And compared to that, the ratio is PB, that is E. So suppose this portion itself only is N. PB is N. Then how do we determine equals to mx2 minus mx1 by n? So we can see that in x2 minus in x1 divided by m minus n, and q equals to mx my2 minus my1 divided by m minus n. So that is our internal and external section. Advaita has asked, when are the 3 points collinear? So Advaita, whenever the there are two ways to decide this. So one is when the area of the triangle combining or containing all these 3 points as vertices, that is 0. Then the 3 points are collinear. Number one. Number two, if the connecting line of these 3 points are having the same slope, right? I mean, they are all existing on the same line. You can prove it from their slope. Then it is collinear. So maybe what I want to say is, suppose we are given this point, this point, this point. If we can see that these two slopes, slope and intercept everything, and these two slope intercept, they are the same, then they will be on the A line. They will be on the same line. But the more, I will say the a little more calculative, but short way is to find that the area of the triangle containing all the 3 as vertices. That is the way of understanding the existing on the line. Okay, collinearity. Is that it? I mean, what is the condition of it? So I think that, does that solve your problem? You just look into it. Huh? If you have any further problem, you can ask in the discourse or in the if you are from qualifier, then come in the Google forum. Anyhow, we will go to Bharat.
I have a
Yes,
question in this regard. So when we are considering M and N, M will always be considered with respect to A, that is x1, y1, and N will always be considered with respect to B, that is x2, y2.
So basically, the larger value, this larger value we are taking as M, and the smaller value we are just taking as N. Okay.
What I was trying to understand is that suppose we are given the ratio 1:3 and 2 points, then what is the way that we determine which is A and which is B, and which to take as 1 and which part to take as 1 and which part to take as 3? That's what I was trying to understand.
So in this case, there are 2 obviously, as you understand, that 2 things are possible, right? So I mean, one point, this actually is more prominent, I think, in case of here. I mean, 1 and 3, right? 1:3. Now, which one is 1 and which one is 3? Is that what you are asking, right?
Yes. I
Yes.
mean, which point to take as x1, y1, which point to take as x2, y2, so that M and N,
Yeah.
I can determine the relation. That's what I'm trying to understand.
So, general convention is to take the first term as M and the next one as E. Having said that, we always know that there can be some student who can take the first value as in and the next value as in. So what we do generally is that we say that either of the 2 options are possible. I mean, either of, if you take so there was a question, I think, if so one row was cut in between 10 meter and 20%. I forgot, I mean, maybe this batch or previous batch. But so what can be possible is that even if you take one term as in and another term as in, or one term as 1 and another term is 3. See what will happen. Basically, you will get 2 sets of answers. Okay. So you can write either of them. Then if it is an NAT numerical answer type, you can write either of them. We have already taken care of that. Or in case it is an MCQ, MSQ, then only one of those 2 options will be dependent. Okay, so that this confusion you do not face.
Okay, thank you so much.
Okay. So this is actually quite. I mean, we always will take care. If something like that comes, we will eliminate that problem. This will be taken. Okay. So with that, we will go to anyone else have any question on week 2? Yes, we'll go to week 3. Anyway, we may also come next week for week 3, but you can ask if you have. Bharat Mahindra has asked. We'll go to. Okay, you can post in the chat box. Week 3
So
practices. Yeah, please go ahead.
yeah, so the question number 10, it's given out that there is a gas equation formula, PV equals to RT, and we're basically
This
supposed
is
to perform
sorry.
SSE.
Who is this? This is my
Sorry, this is
Bharat.
Bharat. This is Bharat, yeah.
Yeah. Okay. Let me just find out the question. Three. This is from practice assignment.
Practice assignment, yeah,
Second practice assignment.
question 10.
Yeah. So what happened? This is an SSC question.
This is an SSE question, yeah. So I'm unsure why are we using V and R's values to derive, you know, so the equation is PV equals to RT, and we just use the 16.6 for V and R is 8.3, and we divide it and come up with the T is equal to
Just
2 twice of P.
Yeah. So basically, whether we are taking the same equation and we are not using it a different but easier equation, is that?
Yeah, why are we straight away dividing it off? I mean, we don't usually do this. We generally take the values, and for SSC especially, we generally take the values and start, the computation with different
Yeah. So
number
you
of
so
terms.
they have just used the different equation in this.
They use the same equation, but they just reduced that P is, P is equal to half of T. So I was not sure when to use it or why they've done it in this particular problem, whereas we don't usually end up using this solution anywhere else.
So is that that is changing the is it the changing the SSC base
It
fitting
does.
line?
I mean, my SSE was coming like a huge value. As you can see, the terms are
No, I
pretty
mean
big. 1/3.
the A. Sorry. This is the question 10. Okay, no,
Question.
sorry.
One sec.
Sharing.
Your screen is not being shared.
Yeah, this is the practices.
No, not this one.
Oh,
3.2. This is 4.2.
oh, sorry, this.
Yeah, 3.2.
Yeah, so one thing is the base fitting line is not changing. Then
It is not
so
changing.
that is the,
Correct.
yeah, then it is okay. I mean, then whichever
No, but
equation you take, it is easy.
sorry, but my answer is coming wrong. No, the one of the options is SSE calculated by B is 14, and obviously
Okay.
my SSE is coming to be a huge number.
Okay. Yeah, so in
Yeah,
that
so
case, I will suggest that see if it has used, then yeah, then you can use. I mean, if it is solving your purpose, I mean, see, if it is helping us in calculation, then it is okay to use that. But if it is, I mean, generally, yes, as you told, we should not do that. I mean, whatever equation is given, the fitting equation is given, we use that on. But yes, if it is if it is reducing our calculation complexity, then I think it's okay to use. Now, it is giving us a wrong SSC value if we take the exact equation? Yes, that is true.
yes,
I
it's
agree.
question
I mean,
number 10.
yeah, it should not.
Yeah.
It should not take that.
Because I'll have to check my values now, scroll back and check it. But
Yeah.
so
this,
see,
this is
it's
this one
SSE.
calculated by AAs. Yeah. So this part you are telling, na? P equals to half of
Yes.
because the values are quite big. That's why this problem. Yeah, it's okay. I
So
mean,
is there like a template when I should follow this, or generally if I see
no. I mean,
it's easing my life, I mean this is the
yeah, if it is
calculations.
easy, yeah, if it is, I mean, using the calculation, You can follow. Should not be an issue. Okay. I don't think and the fitting equations for both the cases are giving procedures are giving the same value, right? I mean, not giving the same value, but I mean giving the same best fit. So from that aspect, I think you can modify the equation. But yes, as you and the method you took, that one is more suggested. That is my personal suggestion that you can use that. That one is the more, I mean, correct method, more correct.
Which one?
Okay.
I'm sorry,
That
the
you-
one where
that
we're
one you-
resolving
Yeah, I mean without modifying the equation.
without.
But
Okay,
yes, yeah, without.
but that gives me a wrong solution to this question.
No, wrong solution is, yeah, the SSC calculator is that.
Yeah, that one, of course.
Yeah, I understood. But
Okay, I'll try to resolve to
it
both
is-
of them.
Yeah. See,
Ah,
it is giving the same, indicating the same line. That is what is
yes,
required.
yeah.
So that is actually teaches us something that you can do. I mean, if you have the uh, an equation like this, and you see that if you modify the equation a little bit, I mean, maybe varying the constant, taking it from one side to another side is reducing the equation complexity, you can do it.
It's simply 2p
Okay.
minus t whole square.
Sorry,
Yeah, it's the
2p
same. 2p
2p minus t
to
whole
t.
square.
2b equals 2b
2p
minus t.
2p minus t whole square is in a SSE, is it?
Yeah, that is the SSE equation.
Then that the values are not big, no? It's coming small only. There I
No,
missing.
No,
in
but
by
that's
hand, if
only-
you are calculating.
That is if you've done this simplification by using V and R values. If you don't use those simplification, then you have huge numbers. I mean,
Oh, okay.
then
So it's
I
better
can
to
look at
do
my
the
book.
simplification, is it? It's better to do the simplification first.
In hindsight, when I know the answer, yes, it's better.
Yeah,
But
Yeah.
earlier I didn't know, so I was going for it.
Yeah. See, but what you followed, that is also correct. And that's correct. I mean, there is no way we can, and we should actually include that option. Both of those options, whatever you got. What was the SSE of A you were getting?
Going through a book now, it's a
Okay,
little
okay.
back. I'm searching. for
Okay,
it.
we'll check it.
But it was a very
Yeah,
big
I mean,
number.
what-
Like it wasn't
Yeah.
close to 14 and all these. So I was like, okay, it can't be 40. This is to be definitely
40,
wrong.
40, 40,
The first time I looked at this.
40.
No, it was
40.
very high.
Very high.
No, it was very high. I'm saying it was not even close to 14. So I could not even think that the solutions that
Yeah,
are provided are even close to my numbers. I mean, I've done some work after that, so it's a little. I'll have to
it's
look
okay.
for it.
Yeah, that's okay. That's okay. So basically, that's the main thing. So if it is, see, if it is giving you the exact fitting line and which one you have to go for, then all the methods are correct. And if it is helping you calculation, you can modify the equation.
Okay. So I
Okay,
had another
what are-
problem. If nobody
Yeah.
else has an issue.
Yeah.
Graded
Which
assignment
question?
1, question 2. Graded assignment 1, question 2. If
That is week
if you're
one.
doing that, that is
Week
week
one
1.
or
Yeah.
week?
Week
Week
one.
one, too, we were discussing in. Can you send us in the forum? That would be easier because we have to actually check also. But I'll just. What is the?
It is
question?
just about the theory of it, not the solution,
Okay,
not how to
okay,
resolve
tell
it.
me.
I mean,
Which
but it
question?
does involve. Is the question question 2? I can ask the question, and if somebody doesn't.
Tell me. I'll try. If not possible, I'll just post us in that discussion. Okay. Yeah.
Sure.
Tell me the question.
So question 2 has a a relation problem. It has you have to resolve a few of these A intersection of B, etc., etc. So I'm able to do all that stuff. Get to the last figure, which is A union B is equal to A intersection of B. That is the last
That
figure.
is a
A
sets
union
are
B.
required.
Yes, sets are required.
Then
So A union B is equal to A intersection of B. Though one of the options is either A or B is an empty set. Only then can these two equate to each other or not.
So that is not
Not
true.
sure why that is not a correct option, because if one of them is an empty set, then it's A is equal to A or B is equal to B, right?
This is where. Can you tell me the question?
Question 2. Sorry,
No.
grade assignment 1. Grade assignment 1.
Graded assignment 1 means this current graded assignment.
Yeah, this one. Yeah, GA1. Yeah.
Yeah. What are you?
Question 2 in this. This one. So
Which of the following options is or are true? Okay, fine. So
after resolving both the sides, I'm able to get to that last bit of A union B, A intersection B.
is that?
I'm sorry, I think I couldn't hear you.
Yeah. So your question is why the first option is not correct.
Yes, please.
Either A or B is an empty set. No, see, if we have A equals to B, okay, and if A is an empty set, but B is not an empty set, then they cannot be equal, right?
So if I'm taking first one as an okay answer, I'm so sorry. I understand what you're saying. I understand that if A is 0, then B can't be 0, and they both can't be equal. But if I don't take both of these, all of these options as interconnected, then it made sense to me. But if they're interconnected options, then yeah, it doesn't make sense to add them as
No,
as a right
interconnected option means?
Means ki if option A, either A or B is an empty set, if that is correct, then of course A cannot be equal to B. Or I mean,
No,
or
but A
A
equals to
equal
B,
to
we
B.
have. But A equals to B, we have found from this part. This question part. Isn't it?
Is equal to B.
A equals to B, we are coming from this portion. Just look into it. Let me know. Okay, if there is a problem, you'll just
Okay, no
bring
problem.
us in the
Okay,
forum.
sure.
Yeah, just.
Okay, thanks. Thank you.
Yeah, thank you. Others, week 2, week 3.
Sir, from week 1, can revise the antisymmetric relation topic with any one
So
example?
anti-symmetric is not in the syllabus. Okay. So
Okay,
I
sir.
mean, why is everyone asking about anti-symmetric? In any question was anti-symmetric mentioned?
In the video lecture, sir, I've mentioned antisymmetric relation.
Anti-symmetric relation. Okay, we'll look into it. Okay. We'll look into it. Anti-symmetric. Can you just post us in the discussion forum? We'll also verify whether what I am telling is true, that it is in the exact syllabus or not. Okay. If sir has mentioned,
Okay, sir.
see, basically what is not symmetric, I mean, see, anti-symmetric means it is opposite of symmetric. So I'll just show
Okay,
you.
sir.
Just a minute. Discuss. Basically, we will ask you to. So symmetric relation we know, right? Symmetric relation is. Can you see my screen?
Yes, sir.
Yeah.
Yes.
So yeah. So symmetric relation means that if two elements are there in the set, and if one element is related to B in one way, then the other element is also related to the first element in the same way. Okay,
Yes,
so
sir.
for A comma B is in X, A is related to B, then B is also related by the relation R.
Yes.
Okay. Now, what is antisymmetric means is that yeah. So
If A is related to B, then B cannot be related to A. It is given.
no, that is actually asymmetric. So
Okay.
asymmetric means that A is related to B, then B cannot be related.
Okay.
But antisymmetric is where the only way A can relate to B and if A equals to B. So basically, I'll just show you. Okay, I'll just finish this.
Yes.
So there are symmetry, asymmetry, just a minute. Okay, so symmetric means
If A is related to B, then B should be related to A.
if A is related to B and B is related to A, no, for all A and B are in the set X. So basically, I will tell you. Antisymmetry, as you can see, it means that R is antisymmetric precisely for all A and B. If R comma A, R is relating A and B with A not equals to B, then R E comma A must not. If R E comma B and R E comma A, then A is equals to B. Okay. So how can we actually see this? So okay, ma'am, can you give me some time? I'll just post it in the forum. Okay.
Yes, sir.
I'll
Okay,
take
sir.
some time and I'll write it properly. Okay, this way it will be a little complicated. And just let me
Okay, sir.
think
Thank
about
you,
it.
sir.
I'll just explain to you. Can you just post your question in the forum to write about
Yes.
symmetric, asymmetric, and antisymmetric? Just remind me. Okay, send a
Yes, sir.
reminder. I'll post on Monday or tomorrow if possible. I'll post. Okay.
Yes, sir.
Thank you,
Can
ma'am.
you please there can you explain with one example, sir? Because it would be better with
Yeah,
one
yeah, sure,
example.
sure. I'll just write it. Okay. Just explain with
Okay,
an
sir.
example: antisymmetric, asymmetric, and symmetric. Okay.
Okay, sir. Thank you, sir.
Yeah, yeah, sure. Please,
Yes,
please
sir.
do that. Otherwise, I'll forget. Please do that. Yeah.
Yes, sir.
Otherwise, yeah. Thank you. Thank you. So, other questions? Week 2, week 3, week 3. So, week 2 graded questions. I think most of you guys solved. Is it? Okay. So what we will do is Yeah, I will discuss a little bit on week 3 topics. Okay, if you guys have any issue, you can ask us any questions. So they are in week 3. So week 2 is mostly the basics of coordinate geometry. That is not a question to answer this session, and that nobody can answer. So anyway, defined forms of equations are there in week 3. So general form is there, which we know ax plus by plus c is equals to 0, right? And so there is that same equation can be transformed into different forms. There are slope point form, slope intercept form, slope intercept. I mean, two kinds of slope intercepts. Intercept form and 2-point. So ax plus by plus c is equals to 0, and then from that we can. So slope point form means there are two things are given. One is slope, that is m. Another thing is that 2 points are 1 point. Sorry, 1 point is given. That is y0 and x0. One coordinate of 1 point is given. So that is slope and point. So slope point form. General form is this one: ax plus by plus c equals to 0. There is also a slope intercept form. Slope intercept form teaches us that y equals to mx plus c, which we end up mostly with whenever we are, predicting an algorithm, or I mean not predicting an algorithm, making an algorithm, or in the extrapolating lines. There are other forms also. Slope intercept form is there. So there are y-intercept form, that is c, y equals to mx plus c. The c is the c is the y-intercept. If you take the x-intercept, then y equals to m into x minus d. That is the slope x-intercept form. Both intercepts, the x and y intercepts as well, that also can be given in the intercept form, intercept form. Actually, basically x by a and y by b. So x by a is x-intercept, b is y-intercept. So x by a plus y by b equals to 1. That is intercept form, or only intercept form. Or can be given both 2 points connecting the straight line. So y minus y1 equals to y2 minus y1 by whatever is given, x2 minus x1 into x minus x. After that, we have given you the the conditions of parallel or the conditions of perpendicular of the two lines. So two lines are parallel. If the the a1 into b2 equals to what a1 into b2 equals to a2 into b2. So basically, if the slopes are equal, then the lines will be parallel, and they will be perpendicular if their product of their slopes are minus 1. Okay. Having said that, there are a few other things. Distance of a point from a straight line. Okay. Ax plus by plus c equals to 0. That is ax1 plus by1 plus c divided by root over a square plus b square. So if we have a point, so like maybe to draw a point. And there is another line. Then how do we calculate? And the equation of this line is ax plus y plus c equals to 0. That is the general form. And the coordinate is x1, 1. Then how do we calculate the perpendicular distance? Perpendicular distance from this. So that is the question. Now, what will happen is that ax, so the distance d is distance is d, then b equals to a x1 plus e y1 plus c divided by the the coefficients of x and y, right? A square plus b square. That is the distance between a point and a line. Similarly, so these two can be important. Okay, whenever these two can be made some questions on. The distance between the two parallel lines, x plus by plus c1 equals to 0, and ax plus by plus c2 equals to 0. That will be again another formula that the distance between two parallel lines. So if another line is given, like say maybe another parallel line is there, then if it is ax2 plus sorry ax2 plus by2 plus c2 equals to 0. This is ax1 plus by1 plus c1 equals to 0. Then c1 minus c2 divided by mod minus c2 divided by square plus b square. So square plus b square. Okay, we have discussed the SAC before. Anupam has asked, suggest more books to practice more questions. So Anupam, we take questions from different books and different thought process basically. So if you have seen the qualifier papers, this March qualifier questions. So some questions you will not find. Okay, because like this, so there was one flight, aeroplane, some grid question in week 3. So that was made by a scholar from mechanical engineering. So that's from a research topic. What you can do is maybe just look at different 10 plus 2 level books, whatever is possible, whatever is a standard book, you just take that and solve all the questions. What else you can do is then go a little higher also, if possible. So many of these set theory questions are there. They come in even management exams also. You can look into books for that. Then you can have different questions from coordinate geometry on this is just my personal suggestion. No, I should not suggest any name, okay, because see, if we are suggesting any name, then we should provide that free of cost, or some, so that everyone can access that. We will not suggest it, but just I'm telling you for more practice. What on the top of my head, we can think of. We can think of different, the competitive exam books, whatever competitive exams are there, and see whatever which syllabus. Just try to see that syllabus. If that syllabus is there in any question, that any particular question paper or any exam, those syllabus are there, then you can follow. There is no barrier. So you can check like even GATE syllabus does not have these topics most of the time. Okay? So GATE syllabus will not have. Maybe other exams you can check. Apart from that, already that we will not give you anything which is not 10 plus 2 books. So IITG sets IITG question papers, whatever is there. If you can solve that, that is great. You will get a lot of good complex problems. Okay, but one problem with IIT books that I have seen is that they give us a lot of question formulas and formulae and shortcut tricks, and ultimately all of us get confused. And so do not get confused. We do not need you to use any shortcut trick. Okay, that you be very sure that we will not ask you for a shortcut trick. Whatever formulae we are teaching in this live sessions or in the lecture videos, that all the topics that will come in the question. Nothing outside. No shortcut trick should be required. Nothing.
What is the books you said? IIT books, huh?
Yeah, I'm telling you, those I mean the syllabus. I'm trying to say that follow that syllabus. Okay, so sir, please follow that syllabus. I mean whatever syllabus is there, set theory, functions, relations, coordinate geometry, parabola, straight line. These are the topics. Now, whichever exam has the topics that you follow. Okay. That is the discussion.
So you were referring to IIT books something, no? What is that?
Yeah, IIT books means the class 10 plus 2 books. That also you can prepare. You can practice. It's no, I mean, but that thing is what I was telling. I also I read those. I mean, I go through those, but they give a lot of complicated shortcut tricks which will not be, should not be required. Okay, we take care of the time that it takes to solve with our question, our formula. I mean, whatever basic formula that we have taught, and we give according to that. Okay, there should not be any shortcut tricks required. Okay, and I mean, whatever topics are taught, like in parabola, there are a lot of other topics also. Focus point is there. Then some other things are there in parabola, but those are not taught, right? Whatever is taught is the quadratic equations part and the basics of parabola. So I mean, just note that those topics only you focus. Yeah. Okay, thank you. So that's the topic. So if you have any other question in week 2, week 3, we can solve. Sum square error we have noted. What else is there in? Just go through all the topics of week 2, week 3. Okay? And this is an easy topic, I know. Very easy part, but this will be the most scoring part actually. So all the questions should be correct. Credit assignment for the people of quiz 1, the deadline is on 19th, so we should not discuss questions. We can yeah, sum square error. Someone has asked, we were just discussing about sum square error. So ma'am, can you switch on your microphone? What is the issue? Still a solid.
Yeah, sir, can you please explain when do we use the sum square error in the practical situation? So how do we use it? Because yeah.
So that sum square error is used basically in when we have a lot of linearly varying data points. Suppose, as I was showing actually sometimes before, this linear regression. Do you know what is linear regression? That is also
Okay.
So linear regression is basically a machine learning algorithm. I mean, it's a linear approach and also a, I mean, quite famous supervised. That is also considered supervised learning algorithm. So see, this is an XY graph. Okay. And the red dots are so what is
the deviations? Those are the deviations, the red dots.
No, the red dots are actually the data points. The data points that we have obtained experimentally. So any experiment you do, we will not get the exact straight line. Okay. if you do like say, I'll just show you. If you do like the example that sir was taking, suppose we have a so if you do a resistor, okay, or yeah, the resistor should be fine, right? So if we take a say a 5 kilo ohm, some ohm resistor, okay, so this the current voltage characteristics depend which current. So what is voltage and current? So if you measure at a 1 volt, 2 volt, 3 volt, this is a instance. Okay, this is just an example. So for 1 volt, the value comes like this. 2 volt value comes like maybe this. 3 volt comes like this. 4 volt it comes this way. 5 comes this way. Okay. Now these are our data points. Now the thing is, they are not exactly on the straight line. Okay. Then in that case, what we can do is we can include a fitting line. So the fitting line can be like this one, or it can be like this one, or it can be this one.
Okay.
Now, which one fitting line we have to take? For that, we have to have a numerical formula of a based fit. So ACC is a numerical method, a numerical formula, which helps us to understand which one is the based fitting. Okay. So this kind of situation we will facing, as I told you, machine learning algorithms in research, experimental physics, everywhere. Okay. So ACC, the formula is given to you. As someone was discussing just sometime before, I think that where I was talking. Anyway, so yeah, so the ACC is the sum of squares, these deviations of this linear model, the straight line model from the actual data set. Okay. So whatever data set you get experimentally, the deviations from your fitting of your fitting line. Fitting line means you understand, right? That we mathematically try to fit a model, an equation with the experimental data points or the collected survey data points. So SSC is the sum of square of the deviations. Why square? Because square gives us the all the positive value, right? So basically, we don't have to worry like one deviation is +5, another deviation is -5. Then we are adding plus and -5, and then this becomes 0. So there is no.
Zero.
That actually is a wrong statement, right? Because in that case, there is no error value, but we can see that there was an error value of 5 and 5. So from that aspect, we take the square. So SSC is actually the square of this fitting line equation. So that formula is given that if you are given in number of points such that I equals to 1, 2, 3, and one fitting equation will be given. So you have to find the SSC. So whichever fitting equation has the least amount of SSC value, that is actually your most best fitting line. Okay. So in your exam, what will be given is that you will be given 2-3 equations, straight line equations. You will be given one set of data point, or maybe sometime in assignment 2 sets of data point. So you have to find which of the given line equations are matching with that data point. Okay, whichever line equations are the best fitting with those data. So
Okay.
that is basically basis.
Okay.
Yeah.
Thank you, sir.
Yeah, sure. Achha, so week 2, week 3, no more questions. See? week 4. Week 1, I will check that anti-symmetric, asymmetric thing, whoever was asking, I'll check that and I'll write to the forum. If you are from qualifier batch, you just post in the Google forum. If you are from the quiz one, just post in the discourse. Okay.
Sir, you are referring that 19th assignment is due for submission. Where
Yeah,
are you
the
referring?
graded
Where is that
Yeah.
it is coming like that?
So, sir, are you from the qualifier or are you studying for the quiz one?
From the qualifier batch.
Yeah, this is for quiz one.
Qualifier batch, no?
Yeah, so this session is for both the qualifier students as well as the quiz one students. That's why I was talking.
Okay,
This
the,
is for
the qualifier guys, if they choose option 2, then we tend to see the assignments of week 1, 2, 3, 4. Is that right?
I think then you are going to see from week 4 onwards. But yeah, I'm exactly not sure how the portal will work. Okay, but I think you will see from you will read at least study from week 4 onwards. Okay.
But we were told in the clarification meeting that we do
You will
have
see
an
from
option
week 1.
to. Yeah.
Yeah, so if
But
that is told, then that is yeah, I will be telling now. Yeah, whatever was told in the administration meeting, that you should follow. Then you will be getting from week 1. I mean, if you
then
it
the
was told, then
contents will be changing, is it?
for what? No content
our-
is changing, sir.
No, what I'm telling, my course page, my current
Yeah.
course page.
Huh.
So currently, my current course pages has the assignment marks and everything already listed over there. And if you opt to resubmit the assignments, what will happen to this course?
I don't think you can resubmit your assignments. Okay, maybe you can. Yeah, just check it. Send a mail to submitting, but I don't think you can resubmit your assignment. That will not be possible. Most probably. Okay.
All right. So we don't have any deadline now.
No, now for qualifier there is no deadline.
Okay.
But I mean, don't stop studying. Okay, I mean, yeah, right now due to these restrictions we could not attend. But yeah, whenever the first chance is coming, the question is already ready and sent to the exam center. So
okay.
Immediately there will be an exam.
All right, understand.
Yeah, sure. Please. Yeah, so that was the thing. So week 3 also there is not much issue. I think SSC is finished. That is the only difficult topic. Looks like. So let's go to week 4 and week 1 we'll just week 1 also we'll just cover a little bit. So week one basically have the natural numbers and integers, the first part, and there were a few notations, as we know. There were factorizing and everything. So rational numbers and irrational numbers. Rational number means p, which can be written in a fraction format, right? P by q. That p and q are integers. So irrational numbers are not in the syllabus. That's one. So when a is, as someone was asking, when a is equals to b, then a union b should be a equals to a intersection b as well. Then there was relation. Relation means that yeah, so here also it is given. So for each element in a set, if all the elements are related by the relation R, then the relation is reflexive. If A comma B is in the relation R, then B is also B comma A is also in the relation R, then it's symmetric relation. A comma B is in the relation R does mean it means that A comma A will be symmetric. So, and also if we have a combination of all three, reflexive, symmetric, and transitive, then it is. Apart from that, what we have is the functions and functions. So function has two parts. One is a, I mean, not two parts, I mean 2-3 terms are there. So one is a codomain, one is a domain, one is a range, right? So the sets from which we take the inputs, that is the domain. Set of all possible outputs, that is the codomain, and the set of exact outputs which are taken by the function, that is the range. So there are different ways to calculate range and domain. You know, domain is basically so if it is given in an under root format, then if x equals to root gx, then what we have is that then we can see that gx is greater than equals to 0. For those cases only, the fx will be real value, or fx will exist. So the domain will be, if it is given like in a under root format, fx equals to something under root, some function of x under root, then it will be that function greater than equals to 0. That is the domain. Similarly, if it is in a fraction format, but the numerator denominator both are in terms of x, then we have what we have is that the domain is not equals to, whenever we have to calculate the domain, we can say that if the denominator is not equals to 0, then the domain is then the domain exists. Okay. So, and also the injective subjective thing was there. So for injective, you have to how to calculate injective, you have to check that f of a equals to f of b. So if a function f is given, then f of x is given, then you take two different numbers, or some if you take two numbers a and b, let us say, then if f of a equal, you put f of a equals to f of b, and from there if you can come to, or by solving you can come to a is equals to b, then it is an injective function, right? So two different inputs cannot give the same output. And if the codomain equals to range, then it is a surjective. Apart from that, what we have is the parabola in week 4. Parabola.
So what is that special function domain of special functions they have given, sir? Of x.
Yeah, so that is in the that week 1. I mean the problem
No,
solving test.
just now you were explaining functions and relations.
Yeah,
That
yeah.
is-
Just so basically, those are some hints for typical problems. So there are like generally two kinds of questions are given. Okay, one is the under root and another is the fraction. So basically, ma'am,
yeah, domain of some function with special form. Can you please explain with any examples, sir?
yeah. So basically, it is just a shortcut. So suppose we put a function if x equals to root 2x. See whether we can y equals to. Let's see whether we can 2x. Okay. Now, what is the domain of that? So you can see that the domain of the function is starting from 0 and going like as much up to towards 0. So it is basically for the cases when root 2x. So what we mean to say, so the domain is greater than equals to 0, right?
Okay.
So what we want to say is if f of x equals to is in this form, that root over g of x, then for this function to be real value, what we must have is that this g of x is greater than equals to 0. So the domain of the function should be such that for an x, g of x is greater than equals to 0. So for this case, what we have is that 2x should be greater than equals to 0. If x equals to what we put is root 2x, right? So for this case, 2x should be greater than equals to 0. So if we put say 2x minus 1, then you see it is very touching half. So it is the domain is starting from 0.5, right? So 2x minus 1 should be greater than equals to 0. So let us write whether it comes properly. So 2x minus 1 greater than equals to 0, or 2x is greater than equals to 1, or x is greater than equals to 1. Okay, so this is the domain.
Okay. Okay.
Similarly, so this is for this format of a function, right? That root x. Similarly, if you put say g of x by h of x, right? So you have like the numerator also a term of x and the denominator also is a term containing x. Then what we have is that the h of the denominator term should never be 0, because that is 0. Then we are basically dividing one term by 0, right? That in that case the equation is not valid, right? It does not give a valid solution. So basically the domain should be that h of x is not equals to 0. So, okay. So x is in the intersection of the domain of g of x and h of x.
Okay. Thank you.
So yeah, sure. So guys, maybe there is not much question. We'll end the session here. If you have any question on week 2, week 3, week 4, week 1, also we'll try at least try to answer.
So this pairs this transitive property, it is A, B element of R and B and C element of R, and then pair AC is also in R. This is a general thing, understood.
Yeah.
But when they give only two elements, say A and B, and they ask for transitive property and they say it holds good, Okay, last week they explained, but I'm not sure about it. When only two elements are given, then how do we talk about transitive property?
Two elements are given. So like, is anything else given? Any other information given? Which question was?
No, in this itself, sir, if only A and B is given, and they ask us to find out whether the transitive property holds good. How do we say that?
Actually, we need to check. I don't know whether. So, what was the method?
Actually, how it was
mentioned?
explained is we say it is 1 1 and 2 2. 1 is related to 1 and 1 is related.
Hello, ma'am.
Hello.
Yeah, ma'am. Tell me.
So they said this transitive property, this A and B itself, we take it as the two elements and they are related to each other. That's what it was explained. So at that time it was convincing, but I'm not very sure. That is, I say they gave the Cartesian products A cross A, and we got the set as 1 1 1 2 2 1.
1 1.
So, there's 1 and 1 is related to each other, A and B. That is
1 1. Okay.
And 1 2.
And
1 2.
Again 1 2.
Yes, sir.
Or this is again any other set is given?
No, that's what. No, the set was given as 1 2 3 4 1 2 3 4. A is 1 2 3 4 or 1 2 3, whatever it is.
1 2 3.
2 3. Okay. And A cross A will be all the product of these two, or B, any set.
Ma'am, actually want to can you tell me which exact question was this, or is that, can you mention?
Yes, sir.
I mean, can you mention the exact number of the question?
No, sir, this was just as an example was given.
Okay, okay.
Because I wanted him to explain the transitive property, because sometimes in the problems they give only two elements, and say we had a problem, the snail frog problem. In that itself, I had a doubt about the transitive property. I don't know which graded assignment it was.
Doesn't week 1 activity question.
Practice assignment.
Week 1 activity question. Yeah.
Yes.
So, ma'am, basically, see, even if I mean, generally there are 3 elements required. So, see, if because otherwise, how do we see? I mean, A should be related. First element should be related to one element, and there should be another two pairs, another one pair of elements which are connected. So if it is like 1 1 1 2, and maybe say another thing, I can say that 1 3. Okay. So triangle. So triangle can be in a property, a transitive property. So that if the first so if this 1 1, suppose this is 1 comma 1, this is 1 comma 2, 1 comma 3. Okay.
Okay.
Then this line, sorry for the line. This line relates 1 1 and 1 3.
Okay.
As another line relates 1 1 1. Okay. See, both these lines are related by this line, by one straight line, right? So this is also a straight line. We say we define it as R. This is also we define it as R. Then we can see that this is also related as R. Okay. That is our transitive.
Okay.
For two elements, we so the snail frog fox problem. Actually, I'll see whether I have it here somewhere. Just a minute. This one, right? Suppose the relation R equals to snail, frog, bird, fox, snail, fox is
Yes.
defined on the state is equals to snail, fox, bird, frog. Yeah. So basically, you see, snail is related to fox in this set.
Okay. Yes.
Snail is related to fox, and fox is related to frog.
Okay.
Now, so basically, so now these relations are there. This relation is mentioned. Okay. Snail, fox is mentioned here. Fine.
Okay.
Fox, frog is also mentioned. So
Okay.
what is from this relation containing snail and frog is also there. The snail and frog is also. So snail, fox is there. Fox, frog is there. So two relations are done, and three
Okay.
elements are also there. So there is the
Okay.
third pair also is there in the transitive. I mean,
Okay.
satisfied in the relation.
Okay.
So therefore, that is why the transitive.
Okay.
Okay. Yeah. So maybe guys will end the session now. If you have any question, please ping us in the discourse or in the discussion forum. Okay, we'll answer. And yeah, that's all. Good night, guys. Thank you.